Welcome to this deep dive, especially for you, the learner. Today, we're tackling a really fascinating period in American history.
That's right, the Age of Invention.
Exactly, and how it fueled the country's industrialization. You mentioned this came up in your unit on American industrialization, so our mission here is really to unpack how these innovations reshaped America.
Yeah, it's a great topic because you really see how new ideas and large-scale industry just completely transform the nation. They really go hand in hand.
I absolutely do. So maybe let's just set the stage quickly. The Age of Invention, what are we talking about broadly?
Well, think of it as a time of just intense creativity, rapid technological advancements happening across lots of different areas, not just one or two things.
Okay, a real burst of new tech. And then industrialization. How does that fit in?
So industrialization is basically the shift towards large-scale industries. Think big factories, machinery, moving away from things being made mostly by hand.
Got it. So inventions are the new tools and ideas. And industrialization is using those tools and ideas to build up big industries. How direct is that link?
Oh, it's very direct. I mean, the Age of Invention essentially provided the toolkit, the technologies needed to make that kind of large-scale industrialization actually possible in America. One really enabled the other.
Okay, makes sense. You need the sparks, the inventions to light the fire of industry. Let's dig into some specific examples. The Bessemer process, what was that?
Right, the Bessemer process. This was a really revolutionary way to make steel. The key was it made steel production much faster and, crucially, much cheaper than it had been before.
Faster and cheaper steel. I can already see how that would be important. What kind of impact did it have?
Huge impact, especially on infrastructure. Steel is strong, durable, right? Perfect for big projects. Suddenly, with the Bessemer process, you had lots of affordable steel available.
Like for what specifically?
Well, the most obvious example is probably railroads. You need vast amounts of steel for the tracks, for the locomotives, the rail cars. The expansion of the railroads across the U.S. really depended on having access to all that cheaper steel.
Right. Without the Bessemer process, that kind of rapid expansion just wouldn't have happened, or at least not as quickly.
Exactly. And it wasn't just railroads. Think bridges, the frameworks for factories, even the first skyscrapers. Cheaper steel changed what was possible to build.
Okay, so the railroads, they were clearly vital. Why were they such a game changer for the country?
Well, transportation, mainly. They connected these vast distances. You could move raw materials to factories, and then, critically, move finished goods out to consumers much faster and more efficiently than ever before.
It sort of shrunk the country, didn't it? Made it more connected economically.
Absolutely.
Yeah.
And that directly leads to the idea of a national market.
Okay, so how did the railroads, plus all this increased production, create a national market? Let me see if I follow. Because trains could go everywhere, and factories were making more stuff, thanks to things like the Bessemer process. Businesses could suddenly sell things all over the country, not just locally.
You got it. People in California could buy something made in New York, and vice versa. It created this unified economic space where goods flowed much more freely. The railroads built the network, and the factories supplied the goods to fill it.
That's a fundamental shift. Okay, let's talk people. Thomas Edison, everyone knows the name. What was his big contribution?
Edison was incredibly inventive, obviously. The light bulb is a famous one, but also huge advances in electricity, power generation, distribution.
He didn't just invent things, though, did he? His approach was new, too.
That's a great point. And that brings us to Menlo Park, his lab in New Jersey.
Right. What was special about Menlo Park?
It was essentially one of the very first dedicated research and development labs, like an invention factory, a place designed specifically to churn out innovations systematically with a team working together.
So not just a lone genius in a workshop, but organized invention.
Exactly. It was a new model for how innovation could happen, much more organized and, frankly, industrial in its own way. It became a blueprint.
Interesting. Okay, another big name, Alexander Graham Bell.
Ah, Bell. And the telephone.
The telephone. Hard to overstate that one. How did it change things back then?
Well, it completely revolutionized communication. Suddenly, businesses could talk directly, instantly, across distances. Think how much faster that is than sending letters or even telegrams.
Yeah, for coordinating business spread across this new national market, that must have been huge.
Absolutely. And it changed personal life, too, of course, connecting people in a way that just wasn't possible before.
Okay, so we have new materials, faster transport, instant communication. Now, how are things actually made in these new factories? The assembly line comes up a lot.
Right, the assembly line. It's a manufacturing process where the product moves from station to station.
And each worker does just one specific task.
Exactly. One worker does one thing over and over. As the product moves past them, it breaks down the whole process into small, specialized steps.
And the goal is speed, efficiency.
Precisely. Increase efficiency, increase the speed of production dramatically. Workers get really good and fast at their one task, and the whole line moves much quicker, cuts down time and cost per item.
And the person most linked with really using the assembly line is
That would be Henry Ford.
Henry Ford. And his goal of making cars affordable for regular people, right?
Yes. He saw the potential of the assembly line for mass-producing automobiles, specifically the Model T.
So how did the assembly line help him make the Model T affordable?
By implementing a moving assembly line where the car chassis moved past stationary workers, he slashed the time it took to build a car. I mean, drastically reduced it. Less time, less labor cost per car meant he could sell it for much, much less.
And the Model T really took off. It became the car for the masses.
It absolutely did. It democratized driving in America, and the assembly line was key to making that happen.
Which leads us neatly into mass production. What's the simple definition there?
Mass production is basically making large quantities of standardized products, usually using assembly lines and other efficient methods, which brings the cost per item way down.
So the assembly line is the engine driving mass production.
It's a critical part of it, yes, along with things like interchangeable parts. Mass production meant more goods were available more cheaply than ever before. Things that were once luxuries became common.
Okay, great. So we've looked at the pieces: steel, railroads, communication, the assembly line. Let's tie it all back together explicitly. How did this whole suite of inventions drive industrialization?
Okay, so let's recap. Bessemer process gives you the cheap, strong steel. That's the literal building block for, well, everything. Railroads, factories, bridges.
The physical foundation.
Right. Then the railroads use that steel to create the network, connecting the country, forming that national market we talked about. That allows for trade on a huge scale.
Got it. Network built.
Then, inventions like the telephone allow businesses to actually manage operations across that large network efficiently. Instant communication becomes vital.
Streamlines the bigger businesses.
Exactly. And then, the assembly line and mass production revolutionize the making of the goods. You can now produce enormous quantities, efficiently and cheaply, to sell across that national market.
Which creates more products, lower prices, and also jobs in the factories, right?
Absolutely.
Yeah.
Huge demand for factory labor, which fueled the growth of cities.
Mm.
So it wasn't just about technology, it profoundly reshaped the economy and where and how people lived and worked.
So the learner, you can really see how the Age of Invention wasn't just, a series of cool gadgets. It was the absolute foundation for America becoming an industrial giant. From the materials like steel, to the connections like railroads and the telephone, to the methods like the assembly line and mass production, each piece was crucial. They all interconnected to transform the country.
It really shows how innovation doesn't happen in a vacuum. One breakthrough enables the next, and together they create massive change.
It really does. It makes you think about how these things built on each other. So, the learner, what aspects of this period strike you the most? And what questions does this maybe spark for you? Perhaps thinking about how these inventions kept evolving, or maybe the social changes that went along with all this industry.
Yeah, and it's always worth remembering that these big shifts, while bringing progress, often bring challenges too. Things like working conditions, urbanization issues, topics for another deep dive, perhaps.
Definitely food for thought. Well, thanks for walking us through this fascinating era.
My pleasure. Always enjoy talking about this stuff.
And the learner, we hope this gave you a solid understanding of how invention fueled industrialization. To help lock it in, here are a few questions to ponder.
Can you explain just in your own words the connection between the Age of Invention and America's industrialization?
Pick two key inventions we discussed. How exactly did each one help industry grow?
What was the big deal about developing a national market? How did that change the U.S. economy?
Why were things like Menlo Park and the assembly line so significant for the way industry developed? And finally, number 5. Even though we focus on the growth side today, can you think of maybe one positive outcome and one potential challenge that came out of this whole period of rapid industrial change?